Geometry used to mean drawing with a ruler. Coordinate geometry replaces the ruler with algebra. Pin 2 points onto a grid, give each an x and a y, and suddenly every line, length, and shape between them becomes something you can calculate exactly, with no measuring at all. From just those 2 points, we can find the line through them, the exact distance between them, the point halfway along, and even the circle they might sit on. Two coordinates in, a whole world of geometry out. Let us see how. Every straight line has a gradient, how steep it is. We measure it as rise over run, the change in y divided by the change in x as you move from one point to another. A gradient of 2 means the line climbs 2 units up for everyone across. Once we know the gradient m and where the line crosses the vertical axis, the intercept c, the whole line is captured in one tidy equation, y equals mx plus c. Every point on the line obeys it, and no point off the line does. That single line is now pure algebra. Gradients reveal how lines relate. Two lines are parallel exactly when they share the same gradient. They climb at the identical rate and never meet, no matter how far you extend them. Same steepness, same direction, forever apart. Perpendicular lines meet at a right angle, and their gradients hide a neat secret. Multiply them together, and you always get -1. So one gradient is the negative reciprocal of the other. Flip it over, change its sign, and you have turned the line through 90 degrees. How far apart are 2 points? Draw the horizontal and vertical gaps between them, and a right-angled triangle appears. The distance is simply its hypotenuse, so Pythagoras gives the length, the square root of the change in x squared plus the change in y squared. The midpoint is even friendlier. To find the exact center of the segment, just average the two x coordinates and average the two y coordinates. The halfway point sits at the mean of the ends, dead center between them. A circle is defined by one beautifully simple idea. It is every point that sits the exact same distance, the radius, from a fixed center. Hold that radius fixed and sweep it all the way around, and the path it traces is the circle itself. Turn that distance rule into algebra with Pythagoras, and the equation falls out at once. X minus a squared plus y minus b squared equals r squared. The center lives in the brackets, the radius squared on the right. Read those off and you know the circle completely. What happens when a line meets a circle? Substitute the line's equation into the circles, and the two collapse into a single quadratic. Solving it tells you the meeting points, and the number of solutions is exactly the number of crossings. And the discriminant from quadratics returns as the judge. Two solutions and the line is a secant, slicing clean through. One solution and it just grazes the edge as a tangent. None at all, and the line sails past, missing the circle entirely. Coordinate geometry turns shapes into algebra. A straight line is fixed by its gradient and intercept as y equals mx plus c. Lines with the same gradient are parallel, and when two gradients multiply to -1, the lines are perpendicular. Steepness controls how every line relates. On the right sit the measuring tools. Distance comes from Pythagoras, and the midpoint from averaging coordinates, while a circle is captured by x minus, a squared plus y minus b squared equals r squared. Find where a line meets a circle by substituting in and solving the quadratic. Its discriminant gives 0, 1, or 2 intersections. A few related ideas lie just outside this unit. Working out angles and sides with trigonometry belongs in triangle work, finding tangents by differentiating weights for calculus, and stretching coordinates into 3 dimensions with vectors comes later. Coordinate geometry here is the recap that turns every line, length, and circle into something you can simply calculate.